one important thing, because we have to measure things, is the concept of significant digits, also called significant figures, and precision. But so this is talking about reliable digits, and precision is talking about uncertainty. Right? Whenever we do a measurement, we use some instrument, and the instrument has a least count. Right? So for example, on a ruler, if this is a ruler, and if this is let's say in centimeters, 2, 3, right? And if it is further divided it in 10 parts, this may be 1 millimeter, right? Then using this ruler, the best you can measure is 1 millimeter. If you cannot measure something smaller than 1 millimeter, because then you'd be guessing, because there's not a mark to measure that, right? So in this case, I can say, okay, I measure with it, and if I say, okay, I measure 23 millimeters, some length as 23 millimeters, then this has uncertainty. Right? Because the actual length may have been a little bit over or below that. Right? But I can only measure 23. If I say 23.2, I'm lying or I'm cheating, because I cannot really measure 0.2 with that instrument. This is millimeters, I'm not saying centimeter. Right? So here the significant figures are 2, significant digits are 2. And then the last one has uncertainty of 1 millimeter. So when we take quantities and then we are working with certain number of significant digits, because that's the best we can measure. And then we start doing calculations with those, like multiplication, division. For example, if you're calculating speed, right? So if you're calculating speed, and we'll do more of these, but then you are dividing distance, say average speed, for example, right? Distance traveled over time taken. Now I'll have a number here, right? And a number here. And this would be affected by the instrument for measuring length. And this is instrument of measuring time, like a clock, right? And it will have some least count, some precision, some significant figures. So now the question is, I have 2 inexact numbers, non-exact numbers, and I'm doing a division. What can I say about the results? How many digits are significant in the result of that? Right. So there are some rules which have been derived at for what makes sense when you do work with quantities that you can measure, and then you want to figure out what's the significant figures in the result. So if you're doing multiplication, division, or taking roots, right? So the resulting number of significant digits is defined by the fewest number of significant digits that are present in the quantities. Right? So for example, so this is first rule. If I'm doing speed, right, and if I have say 10.5 meters over 2 seconds, and in this case, if 3 significant digits in the numerator and 1 in the denominator, right? Here we have 3. And here we have 1. Result will have how many significant digits? Significant digits. So here, even though if you did the full division, it says 5.25. These are not reliable. They were reliable but had uncertainty, right? So this, the 25 has uncertainty. And in this case, you can round it, but 5 meters per second is only one significant digit there. Because of the imperfections in our measurement. When we are doing addition or subtraction, right, and we're talking about number of decimal places in terms of significant digits. So if I'm doing, so this is the other row. So if I'm adding say 2.73 and 1.6, then the result will only have 1 because of this, right? There are also the exact numbers. What are exact numbers? Half is exact, for example, or you have like pi, right? Pi is an exact number. Or if you say diameter equals 2 times radius, right? This 2 is exact. This is not a measurement you are doing. The exact numbers have infinite number of significant digits, right? Because an exact number, you know exactly all the way. So if you say 2, it means 2.00000 forever. You know all of those digits exactly. It can't be anything else. There is no uncertainty, right? Pi is an exact number. It's the ratio of the circumference to the diameter. And you can find as many digits as you want. Of course, we cannot find all the digits in that case because that will take forever. But it is an exact number. Okay, so exact numbers are not measurements. When you measure, there will be uncertainty. For example, you may estimate the distance between two cities to be, let's say, 5,000 miles, right? If you estimate a distance to be 5,000 miles, really these 3 zeros you threw in, that's like an order of magnitude that we're talking in thousands of miles, right? Those 3 zeros have no meaning in the sense of certainty. Right? There is really one significant digit in that case. Or I mean, if it was like say 25, then it will be 2. Right? That's so when you do an estimation like this, it's called order of magnitude. For example, if you were comparing the distances between sun and earth and moon, we probably won't be worried if you're just comparing it like that. We won't be worried about the exact distance. We may be saying like this is that many million miles and that is that many billion miles, right? So all those lower digits we're just treating as zero. Those are all uncertain because we're not really trying to measure it. On the other hand, the approximation in general will be closer to the real number than an estimate. Like if you rounded it up to something, you dropped a few digits, then we're talking about approximation. There will be still more significant digits in general than an estimate.